For the first problem, the first thing we're going to do is say what the variables equal. So in the problem, it states that x is 7, y is 2, and z is 4. And also says to write an equation. So it says that x varies directly as y cubed and inversely with the square root of z. So I wrote x equals k y cubed over square root of z. Then I plugged in my variables, and in the end, k equaled 7 over 4. So now it gave me some new variables. K equals 7 over 4, which we already knew. Y equals 3 now, and z equals 9, and we have to find x. So we plug in these variables, and in the end, we will get x equals 63 over 4. Thank you. For the first part of problem number 2, what I did was I made variables for cheers, number of fans, and jubilation. And it said in the problem to make an equation for it, so that's what I did. I did c equals k times f times j squared. And of course, I already have what they equal over there, so I plugged it into the equation. So it would be 1,000 equals k times 100 times 4 squared. And then in the end, you'll get k equals 5 over 8 after you work it out, as I showed. Now, we have to find out the number of cheers if there was 10 fans and the jubilation factor was 20. So I plugged in everything, all the variables that we had, and I did the work. So 5 over 8 times 10 times 20 squared. Then you get 50 over 8 times 400, which would equal c, which is c equals 20,000 over 8. And 20,000 over 8 is 2,500. So that is how you solve number 2. For the third problem, it asks about horses, goats, and pigs. So I made variables for all three of those. So horses is h, goats is g, and p is pigs. And it says horses vary directly as goats and inversely as pigs squared. So you have to make the equation. So it's h equals k times g over p squared. And then the third step I'm solving. So I'm plugging in the problem. So it's 5 equals k times 2 over 4 squared. And in the end, you will get k equals 40 after you work it out, as I showed. And in the fourth step, it asks for how many goats when there's 6 pigs and 10 horses. So you have to solve. So it's 10 equals 40g over 6 squared. And when you solve that, you will get that there is 9 goats. And that's problem number 3. All right, for the fourth problem, first thing I did was write down the problem. And then next thing I did was I found the vertical asymptote and the horizontal asymptote, which is what I wrote down at the bottom of the picture, how I found them. For the third part, I just kind of wrote down the domain range, horizontal asymptote, vertical asymptote, and the h and k, which is the transformation. For the fourth part, I just kind of wrote down my graph, and then I found the important points which I needed to find which side the lines would go on. So I plugged in 3 for y, and then I plugged in, then I solved, and I got negative 2.86. So I graphed that on my graph. And then for the fifth step, I did the same thing, but for another important point, and I got negative 3.33. So I graphed that too, and I made the lines. And another important point was probably the origin, not the origin, but the point where the two asymptotes met. And I put that on my little chart. And yeah, that's how you do your problem number 4. All right, so here we have problem number 5. For the first thing I did was I wrote out the problem. The second thing I did was find the vertical and horizontal asymptotes, which is pretty much just h and k, And then for the third part, I got the h and k for the transformations, the domain and range, and I found the horizontal asymptote and the vertical asymptote. For the fourth step, I started to find my important points, so I plugged in 2 for y, and I got a negative 6 for x, so I plugged my point in, and then I drew my line. And then for step 5, I did the same thing, except I plugged in 8 for x, and for y I got 3.06, and I plotted that the best I could because it's kind of a weird number. And I drew my line, and then that's how I finished this problem. And I graphed it, and I put a little chart with my important numbers on it. Another thing I would just like to add is that it reflects over the y-axis since it's a -1 on the numerator. Alright, for the 6th problem, first step I did was write down the problem. The second thing I did was find the vertical and horizontal asymptote. And then I put the h and k down, as well as the domain and range for step 3. For step 4, I started to find my important points so I could put it on my graph, after I labeled my asymptotes, of course. And so what I did was I found when I plugged in 3 for x, I would get 1 for y. And when I plugged in 6 for x, I would get negative 3.5 for y. And the 4 and negative 2 is the area that is like the middle of the h and k. Like where, I mean the vertical and horizontal asymptote where they intersect. Yeah. So here's my problem. All right, for number 7, all we had to do was make an equation for this. So I got the original, and I added the h and the k to it, and it gave me y equals 6 over x plus 4 plus 2. And for number 8, the same thing. So it gave me the h and k, and I got y equals negative 3 over x minus 1 plus 0, if you want to put the plus 0, I guess. And the x is the h and the y is the k for both of these equations. So yeah.